Rachel.
And I'm Pete.
We're Team 3, and we're creating a Battle Frog Rube Goldberg. We're making physics more fun in a complicated way. In this presentation, we will be updating our project management, as well as talking about our external research that was performed and our internal research. So we'll talk about our intellectual research and our concept generation and selection. We will also discuss on how our product could potentially fail and how we could change our design in order to make it better in our failure modes and effects analysis. And we will also be giving a proposal to VTEPs incorporated in our economic analysis section.
At this point of the project, the team is moving from phase 2 to the phase 3 of the design. We had finished design review and we are also starting prototyping. And we had also met and discussed with other teams about how our project worked and the ways that it would move, just to figure out the failure modes and effects and analysis. And then we went and discussed with the team the product specifications and what we could fix. Moving forward, we'll also be entering phase 3 that deals with testing the actual design and the product and then refining. The main part of the project that we will have to be refined is where it turns and where the wheel is, because that would be causing the most issues, if any. We had also made a design structure matrix to show our couple of tasks and to show the duration of our other tasks and how long each would be taking. For prototyping, the team had also been efficient and cost-effective with materials to get what the customer wanted and needed. Claire will later discuss the failure modes, effects and analysis, and economics will also later be explained.
So in order to create a product, external research was necessary. This was in order to figure out our limitations on our product and the ideas that we could leverage from other products. The 3 patents shown on the screen here indicate the 3 designs that we already have incorporated into our product. The continuous servo motor we revealed that has a patent that is not expired, and that's an additional cost that our team would have to take on. The omnidirectional wheel and the ping pong ball are elements incorporated into our design with patents that are expired. Using these research designs helped us understand how to better make our product work and how the ping pong ball will best travel in our product. Additional design elements that we researched were non-traditional and not necessarily in the same field, but had design concepts that we could leverage into our product. For example, a horse walker and a windmill had lever arms that were different but had the same general concept that we had. This allowed us to identify where we needed to make our product different and how we can incorporate other elements from other designs in.
For the concept generation selection, we first went through and conducted a 635 method where we looked at or came up with different potential solutions and discussed them as a group. And then we employed the gallery method where we looked at our different potential solutions and got feedback from the class and determined the top 3 solutions. So the top 3 that we established were: one was was a ball that rolled down a ramp and bounced between 2 lanes. The second solution was a circular rotating device with lever arms attached that were cupped, so that this could cup the ball and would be actuated by a servo motor, and the velocity would be programmed by the student, and this would rotate or make the ball travel around the rotating device. And then for the third solution, a lever arm device was at the top, actuated by a servo motor, and that would hit the ball down a ramp, and then a velocity sensor would be at the bottom to calculate the velocity at the bottom of the ramp. And then, so after we went through the concept generation, we selected our concept based on our design structure matrix. And for this, our top 5 factors that we used to rank the different solutions were construction material, complexity, assembly, ball movement, and troubleshooting difficulty. And we ranked the ones that were based primarily on user experience to be the highest, so that to emphasize that our user experience was our main priority. With that, we chose the second solution, which was the actuating rotating device with the cupped lever arms to translate the ball. And this was to display the relationship between translational and rotational movement And we chose this because the ball movement was ideal for this because all the electronic components are beneath the rotating device in the center. So the ball would be able to move freely and smoothly without any wires or electronic components in the way. It was also a very simple solution with very minimal construction material and was the easiest for the user to actually use.
So after we developed the idea and selected the one that had the best capabilities, we decided it was necessary to identify the potential failures of the design. Most of the failures came from the rotating lever, which could fall off the device, graze the ground, and deflect the ball, and the servo motor, which could rotate incorrectly. If the rotating lever fell off the device, it would cause the ball to not travel in the correct path and would affect the overall rotation of the design. If a wheel were to graze the ground, this would have the worst effect to the design because it would cause the most overall damage, especially to the servo motor, and this resulted in that potential failure having the highest risk priority number. The servo motor could have a long lifespan, which would cause that the servo motor would become uncalibrated and would not rotate correctly. So this created changes in our design that would create more lever support for the arms, increase the distance between the wheel and the ground in order to create a smooth spinning. We would change the angle of the lever arms in order to consistently catch the ball every time, and we would make the wheel removable in order for the customer to access and service the servo motor. Peyton will now talk about the economics.
Moving forward with our economic analysis for the project, we had to calculate the loan that BRG needed the BRG loan we needed for our project to take off. We had determined the cost of quarterly building, product development, marketing, and as well as materials costs. We had started with a cash flow diagram, and that would show when and how much of the loan we needed and when and how much of the payback we would have in the payback periods. We also then calculated that the MAR would be used at 12%, which would be a 3% quarterly rate, and we used 12 quarters, which is a total of 3 years. And the cash flow diagram also calculated how much of a rate of return we would have and if it was good or not for the company. It was estimated that our product would take about 8 months to develop, and that would take the first 2 quarters as shown on the CFD. With an 8-month development period, we would also need the loan in the beginning because we would not be bringing in any revenue. For the first 2 quarters, we had estimated $12,600 cost for building, $26,000 worth of product development, and $7,000 worth of marketing, and this costs are all per year. So for the total per year for our BRG, we had determined it would be $45,600. We had proposed a loan to VTEPs that would be $45,000 for the start of our project and then at the end of the second quarter. We would also need a $225,000 loan at the end of the 6th quarter in order to proceed with our project. For paying VTEPs back, we would pay them an amount of $30,000 for quarters 3 through 6, and then $250,000 from quarters 9 through 12. This would amount to the MAR of 12%, and this would show a good rate of return in order for VTEPs to invest in our project and for it to succeed.
In summary, we are in the 2nd design phase, moving on to the 3rd design phase. We have looked through our intellectual property of our different components within the product, and we chose solution 2, which was the rotating device with the lever arms, which displayed the relationship between translational and rotational movement. And we also conducted an FMEA analysis, or FMEA, and we are asking for an initial investment of $50,000.